Thank you, Attila. Thank you for this kind introduction. Thank you to the organizers for inviting me here today to this extremely interesting opportunity to exchange views and to learn from different perspectives and angles on a key issue. During the next 15 minutes, I will focus on the scientific challenges that we face when comparing conventional and alternative fuels. So the focus will be very much on transportation fuels, even more so on road transportation fuels. So the scientific challenges when comparing the performance in terms of greenhouse gas emissions and energy efficiency of conventional and alternative fuels. More specifically, I will be highlighting some key messages from a study that's the Well to Wheels study, which is jointly developed by the Joint Research Center UCAR and Kankawe, which is doing exactly what I've just said. I will also provide some key results from a study that looks it's a scenario-based study that looks at the uptake of alternative fuels in the European fleet at time horizon 2020 plus, say 2020 and a bit beyond that. So let's start with the well to wheels. Again, due to time constraints, I will not be particularly scientific in my presentation because I will be able to provide key messages, really. There's plenty of technical backup slides that I have enclosed in this presentation. Plus, I'm obviously very much available for a discussion on technical aspects after the presentation. So what's the objective of the well-to-wheel study? The objective is that of establishing in a transparent and robust manner a consensual analysis of what is energy use and greenhouse gas emissions for a wide range of different fuel options and powertrain options, which are relevant in Europe at a given time horizon. As you saw on the previous slide, the first version of the Well-to-Wheels was released in 2003. The most recent version was released in 2014. We used time horizon 2020 plus there. And we're working on the next revision. Now, as you can see, what we're doing in the analysis, we're really following the performance in terms of energy efficiency and greenhouse gas emissions from the well or the field for that reason, depending on the fuel that we're looking at, or the power generation, all the way through the different steps of production, transportation, distribution to the tank of the car. And then we see what happens in the car. And we come with pathways that are broadly comparable because they follow the same methodology. Now, we often get the question that the question why we're not doing a full LCA, a full life cycle assessment, not taking into account the greenhouse gas emissions and energy costs that are related to the production of fuel, the facilities for producing the fuel, for distributing it, the energy costs again, and the emissions that are needed to produce the vehicle and for the end of life disposal of the vehicle. Now, LCI is a much more comprehensive methodology which is capable of providing full information about a single process. Now, it's much weaker when it comes to comparing things and trying to compare methodology, to compare technologies that are substantially different. Plus, existing studies such as, recent studies from MIT, for example, the contribution of vehicle production, for instance, is a relevant one, but it remains fairly constant across different vehicle configurations, which supports us in our decision to say, right, let's focus on the well-to-wheels there, and then there's additional chunks, so to say, segments that can be added. And in fact, that's what we're doing, because technologies change, technologies evolve, and in the current revision that we expect to release at the end of 2017, we will have a dedicated module without disrupting the well-to-wheels technology, but we will have dedicated module looking at LCA aspects, so going beyond the well-to-wheels methodology for a selected set of pathways that we understand are very likely to show a different behavior when taking into account aspects such as end of life of vehicles or vehicle components. Now, what kind of messages can be derived from this study? Let's take some examples, and I will quickly rush through them. What happens to crude oil derived fuels? Well, our study informs us or tells us that unconventional oil sources are not expected to impact Europe during the study period, so up to the period 2020 and slightly beyond that. The marginal source of crude oil for Europe remains the Middle East. Now, I highlight the word marginal, right? This is the incremental approach that we're using in the study. We're asking ourselves, because the purpose of the study is that to be useful for decision makers, is to say, what is the next unit of energy that you will be using? It's not the average, because when deciding on investments and making economic decisions, you're not taking a decision on the average, you're deciding on the marginal, right? So that's the approach that is taken in this study. Again, it is further detailed in the backup slides, providing more information in details on the methodology. Another type of message that can be derived from this type of study, if I look at natural gas, what do I see? I see that the green part, which is the transportation to market, plays a big role. And it requires significant energy in the well-to-tank part of the pathway. So I could infer from there that if shale gas was to be produced in Europe, it would display a favorable energy and greenhouse gas profile. Other example, biodiesel. Now here you see that there is a variety of results. So does it make sense to call it biodiesel as such, or put the emission profile of biodiesel is such and such? Not really. It's very much dependent on the feedstock that is used to produce that biodiesel. What happens to the products that are produced along the chain is relevant for biodiesel, but not as much as it is for the production of bioethanol. Now, by the way, I mentioned bioethanol. Again, the fuel types that I'm not presenting here are all included in the backup slides, and there's biomethane, bioethanol, synthetic fuels, hydrogen from fossil fuels, from fossil sources, they're all included in the backup slides. Coming to power generation, what do I see? I see that the EU mix that we use as a reference gives greenhouse gas emissions that are close to producing electricity with state-of-the-art technology using natural gas. Now, one reasonable question is saying, what the hell is an EU electricity mix, providing that power is generated? It's not generated at EU scale, right? It's generated at regional scale, most likely. We're using that, again, because we want to compare pathways across Europe, and therefore we use a reference value, which is the EU mix. At the same time, we're very well aware of the fact, and because electricity is relevant and comes into play at every single step of the well-to-wheels analysis for all pathways, you need electricity for everything. At the same time, we have maintained all the separate pathways because we are aware of the fact that they users of the results of this study may well decide to build their own electricity mix, which is relevant for their context and their reality. I picked hydrogen from renewable sources as a last example for the well to tank presentation, because we can see from this graph that if we decided, or if the decision was taken to produce hydrogen for transportation from wood or wind electricity, this would have a very favorable greenhouse gas emissions profile. But the big question to ask there, and I will come back to that later, is the hydrogen route really the best way, the most efficient way of using these limited resources? Limited either because of their availability, could be the case of land, for instance, or limited because of our capacity to exploit those sources, as could be the case for sun, for instance. I will come back to that consideration later. Now, moving on to the tank to wheel, this metric gives you an idea of the type of vehicles and fuels combinations that we look at. So it's basically, I wouldn't say everything with everything, but there's a considerable range of combinations that we're taking into account in our assessment. Now, I understand that I'm asking an act of faith from your side when I move from that matrix to the results. But there's again part it will take me half an hour to go through the methodology and what we're doing and the modeling and the simulations and the vehicle characteristics. So this is the results. More information are in the backup slides. What kind of conclusion can you draw from such a dispersed, really, graph? Well, the results for the various vehicle technologies and fuels span a wide range, both as far as energy efficiency is concerned and the greenhouse gas emissions profile. Yeah. So one message that I would like to invite you to remember is really that there is no silver bullet solution, that there's no good or bad solution. There's a range of solutions that may be more or less suitable for a specific situation in a specific context, and that possibly looking at metrics such as greenhouse gas emissions is not the only metric that is out there, and it's not the only metric that is informing decision making. What kind of considerations can be made when looking at tank to wheel results? One example, for externally chargeable vehicles, if I compare the performance of vehicles using the EU mix of electricity for 2010, I see that overall hybrid vehicles are more energy efficient than conventional internal combustion engine vehicles. Now, if I have electricity as the main motive power, I could achieve further reductions in greenhouse gas emissions. But if I take into account what the EU mix is for electricity on the well-to-tank part, I see that the gains are modest. So what is the message to the decision makers? The message is, well, fair enough to consider electromobility as an interesting opportunity, but you necessarily have to look upstream to see what happens before the vehicle itself if you want to be effective in your decisions. Another example, for instance, here, if I see what is the effect of the electricity source on the emissions, I see that if I use green electricity, say, to run my electric vehicle, then it's the battery electric vehicle that turns out to be the best in terms of emissions levels. But conversely, if I use a heavier or a more greenhouse gas, a higher greenhouse gas mix of electricity, then it's not any longer the battery electric vehicle that is the best performer, but it's really the plug-in hybrid electric vehicle with a 20-kilometer electric driving range that comes out performing best. And there's no technology reason for that. It's very simple. It's that the electric driving range is reduced, and therefore the overall result is better. Now, I mentioned when asking the question, what is the most effective use of limited resources, and is necessarily the transportation solution the most efficient one? We've asked ourselves this question. This is an example. Other two examples are in the backup slides. We've asked ourselves the question, what if I did something different? So what instead of thinking of my pathways that I'm analyzing and assessing with the different combinations, what if I say, well, with 1 megajoule of wind electricity, I could produce hydrogen for vehicles, I could produce synthetic fuels, I could replace coal electricity with wind electricity. Where is the biggest reduction potential? So this is really an example. The other two examples in the backup slides refer to what do I want to do with a megajoule of natural gas, or what do I want to do with a hectare of arable land? What is the most efficient use of those resources when it comes to reducing, to avoiding the emissions of CO2? This is a very relevant question because transportation sector cannot really be considered in isolation from other sectors, and when making decisions, these decisions should really be comprehensive as an approach. So coming to a conclusion for the well-to-wheels analysis, first, a big reminder, the well-to-wheel pathways are representative of an average or typical European situation. There is an implicit assumption in that which implies that impacts are the same wherever they occur. Now, this can very well be the case if we're looking at greenhouse gas emissions, which have an impact at global scale, but it is not true. It is not a valid reasoning for other metrics where in fact the effects are heavily dependent on local conditions, and air pollution is a clear example to that. So the key messages that I would like you to take home after this presentation is, considering that the well-to-wheels analysis is an essential basis to assess the impact of future fuel and powertrain options, because both the well-to-tank and the tank-to-wheels segments contribute to the overall performance of transportation sector and of vehicles. There is a common methodology, a dataset that has been developed since, say, 2003 when the first report was released. That analysis is continuously updated or periodically updated and includes new technologies as they evolve. Again, key message, transport applications may not maximize the greenhouse gas reduction potential of alternative and renewable energy resources. There is no good or bad solutions. The specific pathway is critical. Yeah, so there needs to be an assessment of the specific pathway. I think the example of biodiesel was quite instructive on that. In general, a shift to renewable routes or low-carbon routes for transportation fuels offers greenhouse gas reduction potential, also because otherwise you ask yourself, well, would you do it? But generally it requires more total energy. So a comprehensive approach across, if not all energy using sectors, certainly across all energy intensive sectors, is essential when making decisions or when informing decision makers to reduce consumption and greenhouse gas emissions most effectively. Now, I will use the last few minutes of this presentation to, again, ask you for an act of faith, because I will be presenting results without providing much background on how we came to those results, but they are well present and illustrated and available. So we've done a study to see what is the expected uptake of alternative fuels in the European fleet at time horizon 2020. What is the capacity of this sector, of both actually the energy and the transportation sector, to meet the requirements of the Renewable Energy Directive and the Fuel Quality Directive? Now, again, jumping to results. There's in the model that we have developed, there's the assumption that activity and stock size will grow. So one conclusion that may be derived is that the decrease in energy demand results really from significant energy efficiency improvements in vehicles. At the same time, at time horizon 2020, we see that the contribution of alternative fuels is small. The growth potential of CNG could play a significant role, but still this is more visible on this slide when focusing on passenger cars only. You see on the slide, on the graph on top, that in fact you see that it's noticeable that the new sales of alternatively fueled vehicles is starting to change the situation. But when you look at the graph on the bottom, the impact that this does on the fleet stock remains low because it takes time. Now, we've often maybe it's excessive, but we've been criticized sometimes for being conservative in our assumptions when it comes to the uptake, to the sales rate of new vehicles when considering alternative fuel vehicles. And at the end of the day, I can tell you that the first version of this study was released in 2011. When we reviewed it in 2014, our already conservative assumptions had to be even reduced compared to the previous version, looking at what were the actual numbers of sales on the market. Now, there is one element that is key when doing this type of when building this type of scenarios, and it's that you cannot ignore what is customer preference. A previous speaker referred to this. Customer preference will not change overnight, and therefore it is regardless of the technology being available, the infrastructure being available. Certainly these are very important or key steps, but it's not going to change all of a sudden. It's not going to make an impact on the sales and even more so on the stock in a very limited period of time. Now, looking very quickly at conventional biofuels on the supply side, well, I don't think that I'm saying nothing particularly new here. Looking at project announcements, production capacity under construction for conventional biofuels has decreased. In any case, there's a low utilization rate, on average below 50% of the plants that are currently in operation. So we may come to the conclusion that investment in conventional bioethanol and FAME production facilities may have come to a halt or a substantial break situation. When looking at non-conventional biofuels and advanced biofuels, there's certainly a slower than expected pace of development when we consider investment announcements and project announcements by companies. There's a competing demand from non-road modes. Aviation, in particular, is increasing its interest in non-conventional biofuels. There is certainly a cost gap, not only with fossil fuels, but also with conventional biofuels. Now, coming to my last slide, what is this study telling us? This study is telling us that the situation is different, is changing, that there is a wider variety of fuels on the market and type of vehicles on the market, and that is bound to increase. When we're considering the RED and EFQD mandatory targets, our reference scenario does not allow us to get there. We're not getting to the 10% RED target. We're not getting to the 6% FQD target. But the message is really in what has happened between 2009, when RED and FQD were adopted, and 2014, when this study was released and the latest data were available. And that is, there's been a tremendous progress made, starting from basically zero, basically nothing. A regulatory initiative, a policy initiative, has steered the market in a certain direction to create a new segment of the market that is producing favorable results in terms of the performance of the transportation sector when it comes to greenhouse gas emissions and efficient use of energy. Now, considering the global commitments and the commitments at European level, this trend, this pace is bound to accelerate over the next decade, at least, at an important place. Now, this takes me to the conclusion of my presentation. I thank you very much for your attention. As I mentioned, the study reports are available on the web at this address. It's not only the reports, it's also all the spreadsheets with the input data, the calculations. It's all there, available for being used, but also available for suggestions for improvement, recommendations, remarks, which you can direct to the functional mailbox that you see on the page, which lands on my computer in any case. Thank you very much for your attention.